Okay, hello everyone. Welcome to COMP1511 Week 2 Lecture 2. I hope you can all hear me properly and see me properly too. Yeah, say hello in the chat if you can. Okay, all right, well, let's get started. So today we're going to talk about loops and custom data types. All right, and don't forget you can access all of the code that we do in lectures. You can access that all on the course website. All right. So in yesterday's, it was just yesterday, wasn't it? In yesterday's lecture, we looked at conditions, if statements. We looked at relational operators like less than or equals to. We looked at logical operators like and or. And we put these into programs and used if and else statements. We chained if else statements, and we did nested if statements. So all of those things allowed us to be able to select parts of the code we wanted to execute and parts that we didn't. So it allows us to make choices and do different things in different situations. Okay, just hang on one second. I'm just checking my chat. I can't really see the chat. I can't see it, but that's okay. I'll just keep going. So yeah, let me know, moderators, if there's anything. Yeah, good, cool. All right, so while loops, we did look at while loops yesterday. We looked a bit at infinite loops and counting loops, and we're going to look at more while loops today. And we're going to then also look at nested while loops as well. And then we're going to look at custom data types. So there's a lot today. But one thing that a few people asked me about that I think people are still a bit confused about is the scanf return. So I'll quickly just go over that again, just briefly. Okay, so here's just a program, and I have to apologize. I think I used float the other day. You don't use float in this course. Please just pretend that never happened. So I've got int x, int y, double z, and I'm trying to read it in with scanf. So, you know, I've got the %ds for the ints, %lf for the double. Now, scanf is going to tell me how many things it successfully read in. And in this case, the most things, it can only read in 3 things because that's all we're asking it to do. So if the user types it in properly, it's going to give us back the number 3, and we're storing it in this variable here. Okay, so the numbers that the user types in are going to go into X, Y, Z, but then scanf is going to say, yes, I successfully read in 3 numbers by giving us the number 3 back. So that's what happens when it all goes to plan and, the user types in the right stuff. Okay. So let's compile it. Okay, and this is what happens, when you don't prompt the user, they just sit there and forget what they're supposed to do. So let's type in, 2 ints and some kind of double. So, and for next time I run it, I'll put this new line in. That might help. So actually, we entered the right data. So scanf was able to read in the 3 things we wanted it to. It returned 3. And that variable that I've called inputs read, you can call it whatever you like, that's telling us we read in 3 things, okay? But the actual values that we typed in, they're in these variables here, X, Y, and Z. Now, if we don't type in the right stuff, for example, if I type in hello, even if I then type the right stuff after it, scanf is going to try and read in that number. It's going to see an H and go, no, there's something wrong. and it's going to return 0 to say, you know, we didn't successfully read in anything. So up here we can see that it did return 0, and we printed out 0 inputs, but then we tried to print out X, Y, and Z. They were never read in because the scanf, you know, failed because the user didn't type in the right thing. And then that's why we're getting this runtime error saying uninitialized variable accessed. So these aren't initialized because no correct data was entered. So the good thing about this is now we know how we can sort of stop this from happening. We can have if statements now and say, well, if the number of inputs read, in this case, I wanted 3, and if I got 3, yes, I'm going to continue and, you know, do whatever it was I wanted to do, in this case, print. Otherwise, I can do nothing. I can complain at the user in a very polite way. Incorrect usage, maybe give them something to help them do it properly next time. So that's what we can start doing as well. Okay, so let's just try again. And this one, like even if we type in some of it correctly, it's going to return in this case, oh, that's all of them are correct. It's going to return, oh dear. Let me do this again. If we type this in, it's going to return 2 because we've typed in 2 integers. We haven't typed in a float, but it's still going to print out incorrect usage. All right, so hopefully that kind of makes a little bit more sense. We'll be using scanf return again today. All right, the other things we looked at were the if statements, and then we went into loops. All right, so let's look at this loop here. I've got a condition in here, and this is a bit of a weird one. So remember, 1 means true, 0 means false. This condition is just true. So we're asking, is true true? Yes. So this condition is always true. When we've got a while loop, if we have the word while here, it'll just keep doing this as long as this condition is true. So when I do this, if I change into the correct directory, okay. It's just going to do this again and again and again. And I think I said yesterday, if that happens, press Control-C. Okay. And I know somebody asked yesterday, well, what's the difference between an if and a while? Well, if we change this to if, it just either does it once or it doesn't do it at all. So if this is true and it's an if statement, it's just going to say if true is true in this case, let's print this out. It just does it once. It's when we use the while keyword that we can do things repetitively like this. And typically we don't want to do things infinitely. Typically we want to be able to control the loop and stop it after, you know, however many times we want it to go. All right, so that was our bit of introduction to while loops. We did look at a counting while loop. So there's a couple of different ways we can use while loops. One of the really typical ones is the counting loop, which we looked at. We've got some kind of counter, we increment that counter, and there's some kind of condition that can stop our loop when we've done it enough times. Sometimes we don't have a counter. We've just got some other condition. We might not know how many times the loop is going to go through. It might be based on some sort of user input, and we can just sort of more broadly call that a conditional loop, although all loops will have conditions. And then there's a more special case of a conditional loop called a sentinel loop. These ones usually seem to confuse people a bit, but basically a sentinel loop just executes until a special value is encountered. So the user might know, I want to keep entering numbers, and then when I press a negative number, that means I want to stop and there's no more input to come. Or, you know, I'm going to keep entering numbers, and as soon as I enter something that's not a number, that means, you know, stop. Or keep entering characters until you type in N or something for no, or Q for quit. We've got these sorts of values that can signal that the loop should stop. So we'll see these varieties. I'll show you some examples. So this is our classic counting while loop. We did have a quick look at this one yesterday. So our counter is starting at 0, and we check, is our counter less than 10? So 0 is less than 10, so we end up printing, here we go to loop-de-loop. And then we increment our counter, so now our counter is 1. So the next time round in the loop, you know, we're asking, is 1 less than 10? And it is, so we print, here we go loop-de-loop. We increment our counter is now equal to 2. We do this again and again and again. Eventually our counter is 9. 9 is less than 10. We print this out. We increment our counter is now equal to 10. We go back around to here, 10 is not less than 10, and the loop stops. So this is a loop that, you know, behaves well and does stop. So let's try it out, and then we'll, you know, play around with it a little bit. Okay, so it's done what I kind of sort of said. It starts, and here I've added this extra thing here. I've printed out the counter each time, so we could see this is it was the counter was equal to 0, and it printed this. This is just so we can see what's going on. Then the counter was incremented, it was equal to 1, we printed this. The last one, it was equal to 9, we printed it out again. Once it was incremented to 10, it stopped. All right, we didn't go inside this while loop again. Now, once we finish the while loop, the code will, you know, once this fails, this condition fails, the code will jump down to after the while loop and continue executing. So I'm just going to put this printf statement in here, so we can see that, you know, that it keeps going, and we can also see what, you know, value the counter had at the end. So we declared and initialized our counter out here, so we can still access it after the loop if we needed to. Here I'm just trying to show you what's going on. Okay, so once the counter becomes 10, that condition is no longer true. The loop ends and the code executes, you know, down there and, you know, for the rest of the program. And the counter's value is equal to 10, which is what we kind of expected. All right, so that's a counting loop. And we can do all sorts of variations with this. We could start at 10 and go backwards down to 0, which I think we did yesterday. We could go up by 2s, you know, if that was some sort of pattern we wanted. If we went up by 2s, what would we expect it? Like, instead of incrementing it by 1, we're going up by 2, so our counter would be 0, then 2, then 4. Like some situations, you might want to do something like that. So you can vary this. Yeah, all right, so that's a counting loop. And you'll see lots of those and practice lots of those in the course. All right, so this one isn't a counting loop. We don't have a counter to dictate exactly how many times this loop iterates. It's kind of up to the user what they type in, exactly how many times we'll go through this loop. But basically, we still just keep checking this. It's the same principle. We keep checking this condition, and while it's true, we keep going through this loop. And eventually, if it's no longer true, that loop ends and we continue executing. Now in this, I'll go to the code. Okay, So in this one, we're keeping track of the number of mils of kombucha that someone's drunk. I'm not naming any names. Yeah, so the maximum is 2,000 milliliters. And we're basically going through the loop. The user keeps entering in how much kombucha they've now drunk since the last time they entered their information. And we keep adding that to the total. So our total starts at 0. Each time we ring, oh, I haven't actually finished coding it all. I've accidentally deleted some. Each time we read this new amount in, we have to add it on to the total. So to do that, this is a common thing. If we're summing things or totaling things, we'll initialize the total to 0. And as we get more data, we add it on. So I'll say total kombucha mils equals total kombucha mils plus whatever the user just typed in as their latest amount that they just drank. So we're keeping this running total. And it's this total that's controlling the loop, because when the user goes over the max, which is 2,000 mils, the loop stops. And they're told to stop drinking any more kombucha for the day, or I don't know for what. Okay, let's try it. I think I've gotten rid of the stuff I deleted, or I've added back the stuff I deleted. So far I've drunk 0 mils of kombucha. How many mils am I drinking right now? Okay, and then I can just keep entering it. Now, if I'm always just entering a small amount, this loop might iterate many, many times until it stops. It lets me go over the limit as well, but then it says stop. But you know, if I straight away just typed in 2005 or something, you know, it's going to stop straight away, or it, you know, etc. It's going to depend upon what the user types in as to how many times we go through the loop. Yeah, so that's just a conditional loop. You'll see these in all sorts of variations. That they can do all sorts of things. So this is just a contrived example. Is there anything else I wanted to show you with this? You know, and you could even go further, and you could put some if statements in here to just check that the user typed in a valid integer. We're not going to do that. You could check that they're not cheating. So for example, you know, we always want to think how we can break our code. This has a lot of things we could break. I could say 2,000, and then the next time just cheat and say minus 2,000, and then I can still keep drinking more, kind of thing. So you know, if this is a real program, we'd want to correct for all those things, but that's the idea with the loop. Okay, so the main thing is we still have some kind of condition that eventually, hopefully, won't be true, and the loop can stop. And this one, it's kind of controlled by the user in terms of it's their input that will eventually stop it. Okay. All right, now we've got this while sentinel one. So yeah, people tend to think this one's a bit confusing, and that the counting one is kind of the one that makes the most sense, but you might be different. So here, so in this case, the sentinel value is a negative number. As soon as the user enters a negative number, that's a signal to our program that they don't want to enter any more input, right? So the way we've set this up is we've got this variable called end loop, and this is just trying to, my pen's not working. Okay, that's all right. I'll be okay. So this variable here, end loop, we've set that to 0 to say, like, we're thinking of this as a true or false kind of 0. We're thinking end loop false. We don't want to end the loop. And so when we start off, we check, do we want to end the loop? End loop equals 0, no. So we keep going through the loop. Right? I mean, end loop does equal to 0, so we can keep going because we don't want to end it. And we just keep scanning in numbers. Each time we scan in a number, we check if it's negative because we know if it's a negative number, we want to end the loop. So we just set end loop to 1. So end loop is 0 saying false. Now end loop is 1 saying true. And we sometimes call this a flag variable. It's sort of like we're now waving a flag saying, we do want to end the loop, please. So if it's negative, we want to end the loop, we change this loop control variable. Otherwise, we just keep printing out the number and we keep going. So let's just have a look. All right, again, I haven't prompted the user for input. All right, so when we're scanning in numbers, like it doesn't matter if we do them one at a time or we could do a few on the line. Our scanf, they'll sort of be in a queue or a buffer, and scanf can just grab each one with each %d it does as it goes through the loop. That's all good. But eventually, whatever, we end up doing a negative number, and that should now set this end loop variable to 1, and it should then stop the loop. Okay, so this is a sort of common sort of pattern. There'll be some condition in the loop, and we'll set this variable to stop the loop. Okay, so there are a few different examples of while loops. So we'll just do a bit of an exercise putting some of these things together. We want to write a program that reads integers from the user and it sums them up. So it just adds them all up, but we want it to stop when a non-integer input is encountered. Okay, so what I'm going to do, some of it's similar to while Sentinel. So I'm going to copy this code and then we can modify it. Okay, so I guess the main two things that we want to change here is that we want to be summing up the numbers that we're entering, and we also want to stop reading in numbers when we get something that's not a number rather than a negative. So the first thing I'm going to add is some kind of variable to store my sum in, and I'm going to initialize it to 0. Then every time I read in a number, and it really is a number, I'm still going to print it out. I'm going to add it onto my sum. So whatever number the user just entered, I'm adding it onto my sum. And by the end of this loop, every time somebody has typed something in, we've added it to the sum, and we should have the total by the end of the loop, or the sum. Okay. So let's just try that. So at the moment, it's not working 100%. It's going to stop when we enter a negative. We want to change that, but we just want to check if our sum is working. So I've got 4, 1, let's not do anything too hard here, 5, 4. And now if I press a negative number, it should stop and it shouldn't add that to the sum. Yeah, that looks right, 14. So the sum part seems to work okay, but we want to finish our loop now when we get something that isn't actually a number. So to do that, we have to get scanf to tell us, or we have to listen to scanf telling us if it read in a number successfully. So I'm going to make another variable called scanf. We can scanf return, I don't know. or valid input, something like that. So this value, in this case, if the user types in something valid, it's going to type in a number, and scanf will return 1. So each time it will return 1 if it read in a number. So if scanf return, is not equal to 1, if scanf returns 0 or some other error code, we're not going to get 1. We know we have to stop the loop. Okay, so now the scanf, the loop is ending based on this scanf return rather than the actual number that they typed in, because it's ending when they don't type a number. I think that works. Let's check it. Okay. Okay, we've got numbers. We can now type in negative numbers and it should keep going. It should add that to the sum. And now I type in something that's not a number and it will stop. And that's right, 4 plus 3 plus 2 plus minus 1 gives us 8. Okay, so you'll see these types of loops a lot where you're doing scanf and reading in input while scanf keeps returning 1 or something like that. And we'll see other ways to write it later. Okay. So now we're going to look at nested while loops. So a nested while loop is a loop in a loop. And you can even have a loop in a loop in a loop. So if we put a loop inside another loop, every time that outer loop goes through once, that inner loop is running. So just think about the clock here. Apologies if nobody actually really reads clocks like this anymore and you're used to digital clocks. But anyway, if I've got my, my hour hand, by the time the hour hand has just sort of moved from here to here, which I can't show you because of my let's try that again. Nope. Anyway, by the time the hour hand moves, say from the 12 to the 1, how many times has the minute hand moved? I can't hear you answering me, but you know. So every time we go through 1 hour, the minute hand is going to move like 60 times, right? Every time the minute hand moves, how many times is the second hand going to move? 60 times. Then how many times is the second hand going to move every time the hour hand moves? A lot of times. So this is a little bit like nested loops. So the outer loop would be the hour. For every time it just increments 1, we've got our minute loop inside going through the whole 60 minutes. Then inside that loop, if we wanted to really be advanced and do 3 loops, nested loops with 3 loops, every time our minute goes to 1 minute, our second hand is going around 60 times. Okay, so let's have a look at writing some code like this. Now, I'm not going to code up the whole clock, but let's start with this. So I've already just done a simple counting loop, just a one-dimensional one. And we've gone, I'm doing the hours in a day. So if we've got a 24-hour clock, we might go from hour 0 up to hour 23. And each time I'm just printing out the hours. So hopefully that's okay. We've got a one-dimensional counting loop printing out hours from 0 up to 23. But if I also wanted to print it out with the minutes, so maybe I'll just show you what we're looking for. So hour 0 minute naught. A little bit like a clock without the formatting as well. Hour naught, minute 1, hour naught, minute 2, hour naught, minute 3, etc. And then eventually we get to hour naught, minute 59, right? And then the hour gets incremented, but the minutes go back to naught, right? And then we get 1, 1, right? So this is kind of what we're trying to do. So we need a loop for the minutes. Now, if we do it like this, these are two separate loops. Let me just do it. Let me do for max minutes. I could have just changed these all in one. Oh well. Okay. So if I do something like this, I've got a loop for hours and I've got a loop for minutes, but it's just, first of all, let's run it. First of all, it's going to be printing out all of the hours from 0 up to 23. It's going to finish that loop. Then it's going to go and do the minutes from 0 up to, 59. So they're independent loops. One runs and then the other one runs. They're not sort of interacting in the way we want. So what we want is, for every hour, we want our minutes loop to run the whole way. So we're going to put our minutes loop inside the other loop. We're creating a nested loop. Okay. So we've still got our initialization of the minutes. We've still got our condition. We've still got our increment of the minutes. But we've put it inside the hours one. And we don't want to print out two separate things. We just want to print it together. So I'm going to put this in here. So for every minute, we print out the current hour and the current minute. Something like this. Let's just see how it works. Okay, so it's gone through, there's a lot here. I'll stop somewhere. So for example, when it gets to 17 o'clock, 5 o'clock, whatever, it starts at minute 0 and it goes through the whole 59 for that particular hour. Oops. Then it ticks over and like it's gone through this whole loop. It then increments the hours. In this case, hours is going from 17 to 18. That's still less than max hours. We go through the minutes again from 0 to 59. Oops. Right, so we've done that inner loop again. So every time we increment hours, we go through and do this whole inner loop again, so that the inner loop is going around many more times than the outer loop is. I hope this makes some kind of sense. Now, we could add in a third loop with seconds. I'm going to leave that for you to try at home later. Can you put the seconds in? But for now, I'll just leave it like this. So this is sort of a classic nested loop. Just so we can get a better idea of what's happening, I'm just going to get rid of, I'm not going to make it 24 hours. Let's make it 5 hours. Actually, let's make it 3 hours is the max and 5 minutes so we can see the whole pattern better. Okay, so we can see the hour, when the hour's on 0, we go through all of the minutes. The hour goes to 1, the minutes get reset back to 0, and the minutes go through all again. Then we increment the hour, we get the hours 2, but the minutes is set back to 0 and we go through them all again. All right, so we'll do more examples of these, and these are tricky to get the hang of at first. All right, so let's try and use a nested loop to print out something like this. Oh, someone's asking how, instead of 24-hour format, how would we display 12-hour AM PM format? Yeah, we could use a modulus. Yeah, that can be an exercise, and we can do it another time when we've got time. But yeah, that's cool. And then we just have to work out how we know when it went from AM to PM. But that can just be another. Oh, you know, no, we'd know. Yeah, that's cool. All right. So how could we print out something like this, a nested while loop? Oh, well, we'd do a nested while loop. But why would we want to do something like this? Often when you've got board games or computer games or whatever, any kind of game, you've often got sort of a two-dimensional board or a two-dimensional world. And, you know, this might represent different, you know, where the gold is on a map, or boxes or obstacles, or, you know, stuff like this. So this is really handy, and nested while loops are really handy for these situations. So yeah, this is just a pattern, but you can take it further and do all that other type of stuff. So we'll start off with this grid pattern, then we'll try this one here, the triangle that I've called a pyramid, I think. Grid. Oh, look, I've already implemented it. So this works, right? That works perfectly. Why do I need a while loop, let alone a nested while loop? I can do it like this. Well, yeah, this is a problem because hopefully you can see that this isn't really great because, all right, this is a size 5. What if we needed this to be bigger, size 1,000, size 1,000,000? Are we going to keep like copying and pasting things and typing it in? Also, this might be a program, or sometimes you'll have a program where the user will type in how big it wants the grid to be. So you don't then want to say, if the user wants a grid of size 5, print this out. If they want a grid of size 6, print this out, and do all that copying and pasting for the whole, every possible integer. So yeah, this is not great. So let's work on doing it with while loops and nested while loops. So to start with, let's just try and print out, you know, one row. We just want to print out this with a while loop. So start with a 1D. So I'm going to call these columns, or col for short. And I just want to, I'm going to initialize it to naught. I've seen that before. And I'm going up to 5 or size. And I just want to print out, well, basically I'm just printing out the value of col. So let's try this to start with. It compiles. Oops. I didn't even mean to do this mistake. What have I forgotten? I've forgotten to increment my column or my counter. Let's try that again. Okay, so this isn't exactly what I wanted for a number of reasons, really. First of all, I really want a new line at the end, so it's not running into this part here. So if I want to put a new line, just one at the end, I want to make sure I don't put it inside that while loop. Otherwise, I will get a new line every time. I just want one at the end. So I'm putting it outside the while loop. Okay, it's still not really what I want. I might just put a space here. Now I want a space after each one, so I'm going to put it, yeah, in the while loop because I want lots of them. All right, but this was supposed to be 1, 2, 3, 4, 5, not 0, 1, 2, 3, 4. So I'm going to start my counter at 1, not 0. But now I don't have enough. What do I need to change now? That's right. No, I don't know what you're saying, but that hopefully someone's saying we could make it go up to less than or equal to size rather than less than, because that will include the number 5. Okay, so we've got this one row. But how many times do we want to do this? We want to do it 5 times. So actually, we want to put all of this stuff inside a while loop that goes 5 times. We want to have rows. We want to have 5 rows. We can start at row 1. While row is less than or equal to size, then we do all of this. For every time we have a row, we need to print out that whole column, and this is what this does. And we want it to do all of this, in this case, 5 times. So I need to make sure I don't make the same mistake again, and I update my row counter like this. Okay, so basically if you don't look at that, we've got a loop that goes for the row that goes from 1 up to 5. Every time we go through the loop, we run this other loop that is printing out columns from 1 up to 5. And you can sit down and try and trace through it and say row equals 0, and I'll do a little bit of that in a minute. There we go, that looks good. So originally, our row is equal to 1, and we set our column to 1 as well. Oops. Right, but then we keep incrementing our column, but the row isn't changing. So row is 1, col is 1, but now we're printing out our 1, and we're incrementing our column to 2. Actually, this kind of draws it itself. And then we keep doing this. So row is still 1, column is now 2. Row is still 1, column is now 3. We're still in this inner loop, and we're still incrementing column 1 by 1. When we get to 5, we're including 5, we print it out, but then column gets incremented to 6, and then this loop stops and we do our new line. Okay, we don't actually print that 6. And once we do that, our row gets set, our row gets set to 2 because it increments. But then we go through this process again because our column gets set back to 1 again. Right, so we're going to have the exact same thing happen. It'll get incremented, etc. When it gets to 6, it's going to stop and we print the new line, and then we increment row to 3, and then to 4, and then to 5, and every time we print out this whole row with all the columns. Eventually row gets to 6 and we stop. So you can keep continuing, you know, really tracing through it one step at a time if you need to, but that's the idea. Okay. Now, one thing that we can forget to do is if I forget to do this, what do you think is going to happen? No, I don't forget to do that because the compiler is going to tell me that. What if I do it up here? This is more common. What if I do it up here? That looks right, doesn't it? If you just have a quick look. What's this going to give us? That looks weird. Why is that? Well, we're doing row 1 and row is set to 1 and we've set col to 1, but then col keeps getting incremented and we finish this next loop. The next time round through the loop, row is set to 2, but col still has that value 6 in there. We never set it back again. So it's going to look at col, it's going to be 6. It's going to say, well, no, that is not less than or equal to 5. And then it's just going to print out a new line and then increment row again. Row will be 3. Col is still 6. We didn't reset it. So this inner loop is going to go, no, col is not less than or equal to 5. It's not going to run that. It's just going to print a new line. So this is a common thing to forget to do. If you've got an inner loop, you need to make sure you have reinitialized it for every time, if that's what you're trying to do. Okay. All right, one more example and then we'll have a bit of a break. Yeah. All right, so what about this one? What do we think about this one? How do we change the thing that we've already got and try and make it look like this? Now, usually I'd be trying to take ideas, but there's a number of ways we can do this. But if you think about it, when we're printing out this first row, how many items do we want to print out? How many columns do we want to print out in the first row? So in row 1, we want to print out one thing in our column. In row 2, we want to print out 2 things or 2 columns. In row 3, we want to print out 3 columns. Row 4, 4 columns. Row 5, 5 columns. So every time over here, we're always going up to 5 or size. Over here, we don't want to go all the way up to size every time we print out our columns. We want to stop at the same size as the row. So how do we actually do that? And you might have thought of different ways to do it. There's always more ways to do it. So first of all, I'm going to copy this to a new file. Oops. Okay. So here, yeah, it's just going up to size. We just want to, we've already got something keeping track of how big we want it because it's going to match the row number. So if we're in row 1, we want 1 column. If we're in row 2, we want 2 columns. So by putting row here instead of size, we're not always going to get 5. It's going to be 1, then 2, then 3, then 4, then 5. Let's try it. Oh, has anyone done that before themselves? Be compiling the wrong file and running the wrong file and wondering why nothing changed? Okay, so that looks good. And you can make all sorts of different patterns. You can try and, you know, see if you can work out how to get the triangle on the other flip side, you know, play around with it. You'll probably be doing something like this in the labs and shoots as well. All right, so that's your little first taste of nested while loops. You're probably not going to go away today and be an expert on them, but hopefully they make some sense and you'll be able to practice them and sort of get better at them. They're a bit of a brain strain at first. All right, so it's about 5:02. Let's come back at about 5 past and we're going to talk about custom data types. And I'll see if I can get my chat working so I can see what's going on. All right, see you back soon. Okay. Okay, we are back now. Hopefully you can hear me and see me, and I've got my screen up. Okay. And I can see the chat now. That's why I was playing around with the screen a bit. Okay, good. All right. Let's get back to it. Let me find my slides. Okay, we've done all that. Yeah, so now we're starting something a little bit new. Custom data types. So this is where we get to design our own types. We don't have to just be stuck with the inbuilt ones. So let's have a look at this collection of variables. Now, what do you think when you see all this? It looks like a lot, doesn't it? And they're related in some ways, right? We've got, these 4 variables are related to one person. Me, not really. My age isn't really 23 and I don't have lab marks, but that's all related to one person. And we've got all the same information for another person, but they're kind of just scattered around in individual chars, ints, and doubles. So someone's saying I did bad in the lab. Yes. Anyway, so it would be really nice if we could package this up together. And we can do it in a struct. So a lot of people kind of find this confusing. I think of it like, a little bit like when you go to KFC and you can say, please give me the 3-piece feed. And then the server, I don't know what's in a 3-piece feed, but then the person then knows straight away, okay, inside a 3-piece feed, there's 3 pieces of chicken, I would guess, small chips, a potato and gravy, and a drink or something. And it's packaged up. Instead of us going and ordering 1 piece of chicken, another 1 piece of chicken, another 1 piece of chicken, a potato and gravy, I've forgotten what else there's in it, a chips, a drink, it's all packaged up together and given to you in a box. We can write our own little structs that can package up data and put it in a box, and it can have whatever we want, whatever we decide can be the types of the data that are in it. Here's another example. What does this look like? This is really hard to sort of get your head around if you just see all these variables. But, this is possibly related to, 2 different points or 2 different coordinates in 3D or something. So it might be nice if we could have a variable of type point or type coordinate that contains these parts. So structs are sort of compound data types that we can put all of the other little primitive data types we already know about. We can store, a collection of them in there. Okay. So yeah, so far everything can just store one single type, like 1 int, 1 char, 1 double. Structs allow us to store a collection, and that collection doesn't have to be the same type. You can have an int, a char, a double, all in the same struct. Now before we use it, we have to actually define the struct outside of the main. This is us designing it and deciding what we want, what type of data we want in the struct. Then once we've designed it and we've, defined it, then we can start using it in our programs that, have the definition in it. And that's when we get the memory set aside. And then we can, just use them once we know how to do it. It's just like any other variable really. So the first step is defining the struct. So this is when we're deciding what's going to go in it. What are we going to call it? I've decided to call it struct student, and I've decided it's going to have a first initial, a last initial, an int age, and a double lab mark. Unfortunately, we don't know how to do like whole names yet. We don't know how to store them. So I'm just sticking with initials for now. We've got to use the keyword struct, and our new type is struct student. these things inside it, we call these members or fields. I think technically they're members. I sometimes call them fields. Anyway, so that's our struct that we've designed. Now, once we've got that and we type it into our program, but up the top, outside of the main, typically you'd have your hash includes, then hash defines, and then you might have your structs. Then in the main, doing this line here declares a variable of type struct student. All right, so the name of the variable in this case is Brianna. That's the variable name. Oops. The actual type is struct student. So just like when we're declaring, say, a variable, we'd have the type int, and then we might give it a name x. Here the type is struct student, and the variable name is Brianna. And it's this point here where we get the chunk of memory. And when we get the chunk of memory, we can then start filling that memory up with the data that we want. So in this case, we've got a chunk of memory that's big enough to store 2 chars, an int and a double. And I can use the dot operator to say, I want to go into this variable, and for the first initial member, I want it to be equal to b. Then for the last initial member, I want it to be equal to k, like the letter k. And then I can set all these different members individually with these dots. Okay, but we've still got this variable called Brianna that sort of packages it all up. And later you'll see how handy that is when we start using functions and passing data here and there, that we've got it all in a nice sort of a package. Okay, so let's just go and play around with it. Get rid of these. Nope. Okay, so I can do stuff like this. So this is what we've already done. I'm still disappointed my pen won't work right now. Let me just... It's not happy. All right. But, you know, I happen to just fill up all of this data in the same order, but I can do it in any order. I can go in and then say, actually, you know, modify something. Brianna.age equals Brianna.age plus 1. Right? I can go and modify this data as well. Also, you know, how would we print it out? Well, yeah, I'd have to do something like, let's just try it, printf, %c, %c, %d, %lf, right? So it is still a bit tedious at the moment to do this stuff. Oops. Also, this is getting a bit wide, right? If I keep going doing my printf, it's going to be more than the width. So style-wise, we don't want it to go over, if you're using this editor, there's a line here. We don't want it to get wider than that. So I'm going to do it, lay it out like this. And in the style guide, there's all sorts of suggestions on how you can do this. All right, so what do I want? Oh, I've got too many commas everywhere. What have I done? We want Brianna.last. I want age. We want lab mark. Okay. What have I done wrong? Oh, age initial. Okay, cool. This is what happens when you copy and paste, right? You don't change everything properly. So, you know, we should have been able to create this struct, initialize it with data, modify the data, and then we can print it out. Okay, and you could print it out more nicely than that, but, you know, okay, and how could I imagine, you know, the lab marks being updated? Like, how can we read in things and change it? Well, I can do a scanf. Now, when I'm doing my scanf, I'm just, in this case, imagine we just want to change the lab mark. Well, the type of that actual lab mark field is double. So that's what I would do. I'm reading in a double. I'm reading it in. Where am I reading it? Well, I'm reading it into Brianna. Sorry, Brianna, I keep saying your name a million times. Lab mark. But I can't just do that because it's a scanf. Is this going to work? I don't want to, oh, I could print it all out again. And we'll see in future weeks how to get around all this copying and pasting I'm doing when we do functions. Okay, so I can enter a new lab mark, I hope. And, you know, now it's 10. All right, so yeah, there's no way of just saying scanf, scan in the whole struct for me, or print out the whole struct for me. We've got to write that ourselves. But later when we see how to do functions, we only have to write it once, and then we can just use that all the time. All right. Yeah, so this thing here is like a blueprint, right? It's like, yeah, when the people at KFC decide they're going to put a 3-piece feed on the menu and they work out what's going to go in it. But they don't actually, they're not holding any food in their hands. They've just made that decision and they've written it on the menu board. Okay, so it's just the blueprint. You don't actually have a struct. You don't have a chunk of memory until you get to here and you declare it. And now you've got a chunk of memory that's big enough to store, in this case, the 2 chars, the integer and the double. All right, so that's the sort of introduction to structs. Oh, I said create another struct. Let's have a look at this one. Here's another example. We've got struct coordinate. So here I've declared, so this is my blueprint for a struct coordinate. We've got an X, a Y, a Z. But at this point, this is just like a blueprint. Over here, we've actually started using it and we've got 2 struct coordinate variables. So yeah, struct coordinate is the type, point 1 is the name, struct coordinate is the type, point 2 is the variable name. Oops, we don't want to go on yet. So let's have a look at that example. We've got struct points. So, you know, enter data for a point. And And then the user is going to have to enter 3 integers, really. Maybe we should tell them that, but we won't. And I can say .1 dot x, .1, oh dear, dot y, .1 dot z. And of course I need my ampersand for scanf. So I've created a struct coordinate, and that's like a box that we can store our 3 integers in, and now I've set them to certain values. Okay, and again I could print these things out, and we can print them out however we like. We could print them out nicely like this. Point X, Y, Z. Okay. Oh, compiling the wrong thing. That semicolon was missing. What have I done? Oh, I haven't used this yet. Enter data for a point. Great. That's what I've done. So it's got its X, its Y, its Z. Now, when I've got a whole struct, what can I do with it? So can I use equals? Can I say that some struct is equal to another one? So can I say .2 equals .1, which is something we might do with ints? Well, it looks like we can. If I try and print it out, let's see what that does. Yep, it does. We've got, I'll call this P1, P2. When I print it, so whatever. Yep, so we've got, I could use equals and I just get a copy of that point. So now I've got 2 structs that both have the same contents. Okay, so that means, you know, if I say actually let's set .2's X field to 0. .1, will that change .1? Or will .1, is this only going to affect .2? Let's check. Okay, so 5, 9, 10, I don't know why. So first of all, what's happening here is we've created a point P1 and P2. We do a scanf and we put in the data that the user has typed in straight into point 1. And when we print it out, we've got 5, 9, 10. Then on this line, we're saying point 1 equals point 2. This basically makes a copy of the data, the same data, and point 2 has that same data in it. So when we print out point 2, we've got 5, 9, 10. We then go and update point 2. We're changing the value of point 2's X coordinate to 0. but you know, that's not going to update point 1. Point 1 is its own copy. It has its own data. We're updating point 2, which now has 0 for the X component. Apologies, I can't draw it today. Any questions about this? Does this kind of make sense? First of all, why we would do this? Any confusion? The other thing is, can we just start doing maths on it? So can I just say point 2 equals, I don't know, point 1 plus point 1 or something like this? No. Actually, you're not meant to add points anyway, but you know, if we wanted to for some reason do maths on these things, we'd have to do maths on the original components, you know, something like this. Okay. Anything else we need to know? Any other questions? Okay. Yeah, we have to add, exactly, we have to add the individual components if that was something we wanted to do, which, yeah, I don't think you meant to do. Okay, so that's structs. Now, this is just a bit of an intro to them. We'll be using them now throughout the course just as another variable type, and you'll see a lot of them. Let's move on to something similar, and then we'll put it all together. Well, not something similar, something different, then we'll put it all together. So the next thing we're going to look at are enumerations. So somebody just said, if you change point 1, will point 2 change? No. They're both, sorry, just going back to here, they're both separate. So we've got one chunk of memory for point 2, a different chunk of memory for point 1. When we do the equals, we've still got these two separate chunks of memory. It's just that they end up with the same contents. But then if you change any of the fields in point 2 or point 1, it doesn't affect the other one. They're two separate copies. Okay, so let's have a look at enums, enumerations. So these are just data types that allow you to assign names to integer constants. And it's a way of just making our code easier to read and maintain. So by default, the enumerated constants will have integer values 0, 1, 2, 3, 4, etc. So for example, this time we use the key name enum, keyword enum, and then we come up with a name for our enumerated type. So again, we're designing these. So we say enum, we give it some name, and then we just make up or design or decide what the different constants are going to be. So for example, enum weekdays is a very useful one that's sort of easy to understand. We could make up enum weekdays, and then a weekday can either be Mon, Tu, Wed, Third, Fri, Sat, or Sun. So now I've got a variable that can be any one of these sets that we've just, this is like a set of possible values for our variable if we make a variable of type enum weekdays. Down here we've got enum status code. If you don't want these constants to have the default values of 0, 1, and 2, 3, 4, 5, whatever, you can go and hard code some in. So here, this might be something, you know, a website might use. OK equals 200. It might be an error code. Not found 404. There might be others you could add to this enum type. Okay, so that's sort of the idea. And they're like integer types. They're integer types only. So in this example, we've got enum weekdays, we've got Mon, Tu, Wed, Third, Fri, Sat, Sun, whatever. We've defined that up here. Down here, we've got enum weekdays. That's the name of the type. The name of the variable is day. So our variable name is day. It's of type enum weekdays. We can then say our day equals Sat. our day equals Saturday. Unfortunately, if we just print it out as is, if we print out the day number is, it's going to print out 5. Fortunately or unfortunately. It's not going to print out Sat for us. We would have to make some sort of if statement. If the day equals Sat, print Saturday. Else if the day equals Sun, print Sunday, for example. Just by default, this is going to print out 5. All right, so let's just have a bit of a look at Enums. Okay. Oh, it's printed out 0 because it says this will print out 5 and it prints out 0. I've put Monday in there. So the day is Monday. Monday has the value 0. It prints out 0. Now, it's a little bit hard to really show you how useful these can be yet with what we know. But if anyone's got questions now, and then I'll go on and talk about how we can put them and combine them with structs, and these can become fields in structs. But does anyone have any questions first? Now, one question people often have is that sorry, I'm distracted by the chat now. One question people often have is like, what's the difference between this and a hash define? When would we use this? When would we use a hash define? So the enums are really useful when we've got like a specific fixed set of constants. So we want weekday to be able to have something in the set of Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So it's really useful then. If we were using hash define, we would just have to go through and have a whole bunch of these hash defines. Etc. We might then have other hash defines like size, which might have the same things, and you then might end up doing all sorts of weird things with your, if you had int weekday, I'll just call it WD. If we're using hash defines, you could very easily give it Monday or size or any other sort of hash define value. Here it makes it very clear about these are the sorts of values you can put in this variable. It also makes it more compact. Oh, and now it's complaining because I've got other places saying mun and chew. So you can't use mun and chew anywhere else now. Okay. Why is this not working now? Let's see. What have I done? Who can see what I've done wrong? Oh, I've somehow ended up with another bracket there that I didn't see. Okay. All right, I've unbroken it. Yeah, I don't know how I ended up with that. All right, so yeah, I was trying to talk about the difference between enum and hash define. So yeah, the enumerations, they automatically assign values. So, you know, it's less work to go through and type all the hash defines, but it's good for sort of type checking as well, because we've got a definite type called enum weekdays, and it's got definite values you can assign it to. And it just makes the code easier to read. Hash defines are still useful though, because you might have constants that aren't integers, or you might have constants that are just standalone values. Like you might have a program and it's just got max size. That's not a set of values. You're just going to use a hash define for that. Okay. Oh yeah, and people saw that missing. Yeah, people saw the curly bracket. I was just staring thinking, no, what's happened? Oh, all right, we've still got time. Do we want to do a coding example or do a Kahoot? We might even have time for both. All right, let's do a Kahoot. I don't think we've done a Kahoot yet. We could probably still do a coding example. Okay, so I'm going to press host live. It's a fairly quick Kahoot, really. Let's see how we go. Now, usually I'd give you chocolates if you were here in the room. But, you know, if you win this Kahoot, you can come and ask for it next week. Hopefully I've set this up properly. Now, do we want sound? Actually, that might be really loud. Ah. Can anyone hear the Kahoot music? All right, I'll just leave it. I'll have to work out these technical issues for next time. Wow. I'll just give you a couple of minutes to join. Okay. Oops. There we go. All right, are we nearly, is everyone on, or what do we think? Use the, who's trying to cheat? Who's trying to cheat for chocolates? Okay. And you get extra chocolates if there's one that's wrong and you're the first one to realize that the question's wrong. You get, you know, you can get 3 chocolates. Promote obesity. All right, let's start it. Oh, hang on, I'll just, all right, 1 more minute. Okay. Oh, people are still popping in. Okay, let's go. Are you getting that sound now? Is it really loud? Okay. All right, so yeah, you should be able to see on your actual device what the questions and answers are, so you're not lagging. Oh, still no music. Okay, that's better than it being blaring, so that's okay. All right, so yeah, a lot of people got this right. Now this one, it said declares and initializes an integer. So the blue one declares it by saying int mark, but it also initializes it by putting the value 100 in it. Whereas the red one, that declares the variable, but it's not initializing it as well. The yellow one, that's actually defining a constant, not a variable. And the green one just has the wrong way of saying integer. It's int. All right. Okay, Karen Quayle in the lead. Now this gets a bit harder soon because we're doing some if stuff in it. Great, people are doing well. So scanf, %d for int, and we've got to put the ampersand. It's easy to forget that, ampersand num. Okay, let's keep going. And the pictures aren't necessarily related to the questions. Very good. Only 2 people said to make our lives more difficult. Okay. Now this time the question is, the pictures are related to the question. And remember, those vertical lines are or. Okay, so what's going on here is we've got this statement. There are 4 penguins. Now that's true. I mean, you need to know that, yeah, they are cartoon looking ones, but yes, let's assume they're 4 penguins. But then we've got or, they are the same height. They're not the same height, but because we've got or, only one of these things have to be true. So because we've said, because there are 4 penguins and that's true, it doesn't matter that they're not the same height, this whole expression will be true. So with or, only one of the things has to be true, and there are 4 penguins. Okay. Hopefully that makes sense. All right. Okay, so this means and. The 2 ampersands mean and. So there are 4 penguins, true. They are the same height, false. When you and it, both things need to be true. So overall it's false, okay? There'd have to be 4 penguins and they would have to also be the same height, and we don't have that in this case. Yeah, sorry, I'm just laughing. Okay. Okay. So we're checking, is the letter A less than the letter Z? Yes. So hopefully you knew what the question was asking there. Yeah, because all of our characters are in order in the ASCII table, and the lowercase letters are in order, and we can say, yes, A is less than Z, because the ASCII code of A is less than the ASCII code of Z. You don't have to look it up or remember what it is. Okay. Yeah, you do get more points for being fast. I've played one that I wrote and knew the answers for, and I didn't win because I was slow. I actually think I got one wrong as well. Okay, we're getting harder. Okay, good. A lot of people got this, which is good. So 7, oh, I thought my answer was wrong. 7 is less than 15, that's true. But 8 is not greater than or equal to 15, so that's false. Now, if we've got true and false, we get false. Both things have to be true for us to add them together and get true. So yeah, we've got false, so that's good. Not many more now. Okay, good. People are doing well with these logical operators, which can be confusing at first. We've got 7 is less than 15, that's true. So if we're ORing them together, it doesn't matter that 8 is not greater than or equal to 15. It's the overall, the whole thing is true. So that's good. We're up to the last one. Oops, I've got to press next, leaving you all in suspense. Oh, this is mean. This is a hard one. The man looks concerned. Aha. So yeah, this one was a bit trickier. So is 5 less than 10? True. Now, it doesn't matter that 6 is not greater than 13. This whole expression in brackets is true because 5 is less than 10. If we do a not of that, then we have true, and we not that and we get false. So this inner expression in the brackets, 5 is less than 10, that's true. So that whole part in brackets is true. Exclamation mark means not true is false. So that's why we end up false. Does that make sense? These are tough to do with a ticking clock. All right, so let's find out who the winner is. Excited Ferret in 3rd place, Swift Piranha in 2nd place, and congratulations to Yellow Sphinx. Woohoo! All right, and runners up. I don't really know how to see. I missed it. Congratulations to the runners up. Yep, if you're in the lecture on Monday, come up and get some chocolates. All right, so that's our Kahoot. Now we've still got a couple of minutes left. Do we want to design a Pokemon type enum or do the second hand on the clock? let's do Pokemon. Someone's saying early mark. This won't take long actually. So we're just going to call it enum. Now, what do you call a Pokemon type? Is it just Pokemon type, or is there a better name? So what are the different, like, you know how there's like, isn't there like fire, or are these not types? What are these called? Entire Pokedex. It's type. Okay, Pokemon type. What do we have? We've got fire. I've forgotten. Psychic. Oh, I can't spell psychic. Fire, psychic. I've probably missed some. Water. I don't know. What else? Grass. One more. Ghost. And dragon. Now that's our Pokemon type, and I know that that's not 100% accurate, but that will do. So now our Pokemon's going to be able to have a Pokemon type. What we're going to do, we mightn't have time to do it now. We want to define a struct Pokemon. And we're going to have to design and work out exactly what every Pokemon has. So for starters, every Pokemon is going to have a type. Now you might tell me they've got more than one type at the same time. For now, our Pokemons are just going to have a type. So now in our structs, we can have all the ints, chars, doubles, but now we can also have any kind of enum. We could also have structs, nested structs. We won't do that right now. We've got like 2 minutes left. So yeah, in the next lecture on Monday, we're going to complete this Pokemon struct with its enum type. You'll have to help me think of other things we want in this struct. Okay, we'll design it together and we'll, you know, just do something simple with it. So actually, what else does a Pokemon have? Can they have more than one type? They can have up to 5 types. We don't really know how to do that. We could give them 2 types by saying type 1 and type 2. Don't they have something like power or strength or something like that? Yeah, so they could have like double height. Do they have height? Don't they have hit points or power or something like that? Yeah. All right, attack and defense. That sounds familiar. All right. So, you know, we can work it out on Monday. We can fine tune it, but this is the idea. And then we're going to sort of make a few Pokemons. It's not going to be that elaborate, but just to go over how we work with nested structs, enums inside structs, and then we'll look at structs in structs and, you know, and do new stuff as well. All right, I think that's all we've got time for today. Thank you so much, everyone, for coming. I hope I get my hand on some of the tech issues for next time. We'll see. All right, have a great day and see you next week on Monday. Have a great week. Bye.